I know the post-lunch sessions are a little bit dull, like not the sessions actually, but people become dull. So in case you are feeling sleepy, stay awake at the last sessions, at the last part of it. There are a lot of architecture diagram which I am going to cover. So please stay awake. I'm very grateful to you. Like it's completely houseful, I can see. Thank you. Let's begin. So some detail about like most of that she has already covered. We can skip this. So we will first go through the background evolution of data architecture. So I would say we need to know our history to not make mistakes. So whoever like there's someone said this great word is. So whoever don't learn from history or don't go through the history, they often make those mistakes again. So just a recap I'm going to do. So who have seen this data warehousing word? I think most of us have seen, right? Only 1, 2, 3. Yeah, most of them. 1990s, Bill Inman and Ralph Campbell proposed Snowflake and Star Schema. Centralized repository we are making, that's the evolution from database to data warehouse, where we are making centralized center of truth for all our data. I will not cover this. I think most of us are expert in this aspect. It's just going through how the things evolve. 1990s, I was maybe in some schools that time. Then same time ETL process also came. Later on changed to ELT, a lot of us know. It's all how the data is being processed from file system to database to data warehouse, and ETL is supporting data warehouse. ETL is still exists, still supporting a lot of things. Then comes multiple challenges with the data, with the explosion of internet speed, with the explosion of customer serving throughout the world, throughout the globe, velocity, volume, veracity, variability, variety. Like we know, we were about 3 V's came, then 5 V's, then 6, 7. Like it keeps on going. That time, Yahoo, Google, like a lot of big corporates, they were trying to solve this problem. MapReduce, big data system, everything came into the picture. Anyone like written Java code in MapReduce? You know what are the challenges, right? If things break, you keep breaking your head, like try to find out what is going on, like what is error, so much error will come, what is there? It takes a lot of time to figure out. Okay, lot of architecture I have skipped in essence of time. Jumping on the biggest architecture marvels which solve all this 6, 7 Gs, whatever keep on coming, is the Lambda architecture. In 2010, again discussions, and he published, nothing much, published a paper. Anyone knows CAP theorem? In big data, out of 3 things, only 2 you can cover, either the velocity or value, like that, right? So he wrote a paper, failing, I don't remember exactly what was the name of the paper, but it's proving CAP theorem wrong. That architecture he came with, like all the V's can be addressed in one architecture, that he came. Combining batch process, real-time process, again real-time 2010, only big companies were doing that, not all the organizations were doing. Credit card company, a lot of banks, they were doing real-time processing. But it was slow. Whatever he projected in Lambda architecture, it was taking like 10 seconds to 10 minutes. That was the real time in that situation. That time I would say 10 minutes. You are getting something within second to minute or 10 minutes is a real time. Anything 4 hours, 5 hours is not a real time. That's a batch processing that was started. A lot of demerits were there, like complex to implement, multiple, and a lot of cost it was covering. You need to manage tools. I will come to the next slide, there we can discuss. This is one of the implementation. There are many other Lambda implementation can be done where the real-time layer of the speed view and the batch view can be clubbed into one. That was originally started, but later on, a lot of architectures found out that separating the two layers or the two data views will serve the much better process, and that's why I'm presenting this one, not the earlier one. Data source, real-time layer 1, the same source is processed in real time but very short duration. And real-time query can serve batch processing, which is normally 4 hours based on the requirement of the process and the company. 4 hours to 1 day. Everyone was processing like overnightly batch jobs. So what is happening here? You are managing two layers, two clustered or you can say distributed system to manage this, double the cost. Lot of duplicate data is coming, bigger headache for the data engineers, or you can say ETL engineers, or who are developing this data, giving it to clients. Lot of challenges, lot of costs are there. Thanos is sorted from this one. You may remember this slide. I will refer this. Imagine yourself relaxing after solving a huge problem. Thanos 6 V's, 7 V's were solved by Lambda architecture. But as a data engineer, do you think we will get any time like this to stay relaxed? That's a myth. Okay. Code maintenance on the Lambda architecture. Things keep on breaking. So as soon as you are sleeping, there's a dam. Wake up. Something else break up. Wake up. Okay. There's another architecture which is somewhat it handled. The Lambda architecture demerit. Cost also is maintained. So in 2014, they developed this Lambda architecture and he started publicizing it. Sorry? So he simplified Lambda architecture by combining both into two. Little bit detail I will give about him. 2010, while working in LinkedIn, he and his two more associates, we all know Kafka, right? He is the founder of Kafka. Later on in 2014, he founded Confluent, company called Confluent. Last year they were here also. And Confluent Kafka, everyone heard. So that's the company which is serving. So at the back, Jay is the person who has developed it. Two more persons are there. This is what Kappa architecture is. Your batch processing will go to the real-time layer. And multiple parts are there, storage, again batch app is also going to taking data from the same storage, real-time app is taking data from the same storage. I hope this is visible and my voice is going up to the back, right? Or I need to speak a little louder? Thank you. So this is the simplest one, though yeah, it looks simple, but it's not that simple. You remember the slide I said to remember, right? You will face that also. You are not going to get any time to relax. Okay, it's simple than Lambda, but again, a lot of places Lambda also plays good role. Kappa has replaced most of the architecture design where people are moving. Actually, when I say people are moving, the big companies like Twitter, Uber, like who are getting trillions of expression, trillions of events every day, they are moving away because for them, whatever the cost they are paying, their cost will reduce in Kappa architecture if they move. I will come to that also. Here there are like lot of challenges we will come. So generally the Kappa architecture, if I say this one, it works on immutable logs. You know, like Kafka immutable log, it works on that. There are challenges for that. Okay, this is a typical Kappa architecture. We have ingestion layer. Multiple events are coming, going to the Kafka. goes in CDC directly from API, multiple things are there. Then that we are writing in another Kafka layer, what we are ingesting from, you can say the consumption layer, and from there for safety net we are writing it to the object storage. It can be any cloud object storage, or earlier days when it was founded, it was cloud was not that much like everyone was using. Hardly few were experimenting on it. So they had their own Hadoop system on that. They were writing in the log as a backup, and they had that time also Spark, Apache Flame, and multiple other real-time processing engines were there that they were using to process those speed layer in a second to maximum 3-second delay. Then comes the serving layer. Serving layer you can link to any of the data sources to get a real-time view or to get batch view, or you store it into a data warehousing you build. Then you can consume based on your application need. Now comes, let's discuss a little bit of building blocks of the Kappa architecture, what it constitutes. Okay, so there is a data ingestion layer. You can link off Kafka a little bit, not little bit, maximum of the things of the architecture is based on the Kafka itself. So Kafka, we have a producer. Here also in Kappa layer, we have event producers who will be producing the data, as seen here in the ingestion layer. Event producers are there. There we need to, the second part, event type, what it comes here, that is most crucial. How you define your events, that's where most of your logics will come. How frequently you need to update, what is the window sizing. Less in upstream system, anything happens, how you are going to backfill, that logic need to be built first. Second one is the messaging system. There were multiple messaging systems, I think since 2004, 5 I have seen multiple messaging systems were there, and that time those messaging systems were fulfilling the needs of those times application or the needs of the customer. But the need is changing. You need a millisecond event detail. So for that, Kafka is one of the, you can say, revolutionized new architecture came by Jay, and everyone started using a lot of messaging systems which are required for real time are fulfilled by Kafka. There was one more came into place, I think I'm missing out name, Apache Soundja, I think that came, but it didn't succeed Kafka in processing the real-time events. So when I'm talking about real-time events in trillions or billions of events per day. Third is stream processing layer. Now whatever the streams are coming, you need to ingest, that need to be processed, some transformation logic, data enrichment, these things we need to apply. Apache Flink, Spark, Soundja also you can use, Strong you can use, but only two Apache projects were mostly used for stream processing is Flink and Spark. Again, to compare between Flink and Spark, I would say Flink is succeeding in real time, actual real time processing. Flink's coming into play, then Spark. Spark, not ideally real time processing engine, but it serves the purpose. But Flink is the most important for complete real time processing. Then the logic you need to develop, how the real time events will be processed, validated, filtering, what you will be applying, data quality, data governance, everything comes into a logic, and it should be applied on the real time. This was not earlier in the original Kafka. It was added later on and mainly advertised by Uber. So they have introduced a data storage layer because when you are scaling at trillions of events per day basis, Holding that even for longer time in Kafka is very, very costly. When I say very costly, I can say 2 or 3 years back, Netflix, they have given a glimpse how the cost can vary. If they are storing the data, let's say just 7 days of data in Kafka, and the rest of the data they are storing in object storage, their cost is coming around 2 million US dollar per year, I think. But their application need real-time data for about a month, 30 days. Some application more than 30 days data they need. If they try to store everything on Kafka, the cost will go up to about 93 or 99 million, something is shown. That's the variance. So store less data on Kafka, more on the data storage layer. Data storage layer, multiple things are there, like S3, like everyone is using, or GCP, whatever they are providing, Azure they are providing. A lot of Alibaba is also there. Anyone you can use, these are like very stable data storage services they are providing. This is optional. Sometimes you might need a batch processing engine to less complicate the replaying of the events again. So in the case where, let's say you get a lot of data suddenly, or in the case where you need to process large amount of data, let's say more than 7 days, as the case in Uber I said, you can have your own data warehouse, and that can be on Redshift or Google BigQuery, Snowflake. And as earlier said, Delta or Iceberg, the open table formats data lake, or Delta Lake generally I call it. Then data serving layer comes, where we are exposing to the end customer. We can expose via query layer or the APIs, or that data set we can expose them for access. Seventh comes to monitoring and management. That is very important. Like you need to monitor your the events, how the ingestion is going on per second basis. So real-time monitoring. Again, I need to do the next page. The companies who are using Kappa architecture, Uber, Shopify, Netflix, Twitter, Disney, and many more. Uber, they have implemented Kappa for connecting the drivers and the customer together in real time when they are searching how many drivers are available. Like that, they have, and Shopify also recently moved from Lambda architecture to Kappa architecture. Recently means 5-6 years back, not now. Okay, here one case study I have put is of Twitter. 400 billion events in real time is generated in petabyte scale every day. So this is the Lambda architecture which they implemented and ran it for a long time. So this is again presented by Twitter in their Kafka event. So there is the Hadoop system where the big data they have stored in the batch processing layer, then Kafka topics they were using. And this is their in-house built cladding database. You can say the batch processing layer, where data warehouse, a batch data they were processing. And Hummingbird was a platform they were operating. And this I can say in 2010 or 12 they were operating on this 400 billion event at that scale. And then as I have shown in my earlier Lambda architecture, they were distributed two databases, one for real time, one for batch, and combining and serving to the Kappa system to the customer services. A customer can query from there. When we are opening Twitter, that is how the events are coming. Now recently they announced they moved to hybrid system. So the way I am coming, complete on-premises Kappa architecture built up. From there, company started moving to hybrid system. In hybrid, this is the way Kappa architecture they have built, everything going through the Kafka. And the optional data warehousing I have suggested, that is what Twitter LDC query service they have implemented. Data going to the Google Cloud. So Now the tension of Twitter is making sure at least once these events are processed and going to the Google Cloud. Their PubSub architecture is capturing it. That's what they need to make sure. Rest everything coming to the client end through the cloud BigTable, BigQuery. They don't need to take tension of like things are breaking up, some backfilling they have to do. Once it is on the Google Cloud, Google is taking care of everything. There are a lot of detail inside this architecture. I'm just skipping in essence of time. Now, why everyone is shouting about real time? So, in this diagram, you can see if you are processing the data, you are presenting the data to the business leaders in the month days, how it's impacting their decision making. For example, earlier days when we were on data warehousing, historical data we were producing, it was like you can see what has happened earlier. You can't do anything. You can do to rectify it, but it will take time. Next, it goes for hourly, minutes. That was the Spark era. When in minutes to hour data processing was done, we were calling it real time or near real time words were given. Here also we can make decision, but it was not, it was reactive decision. Something happened, now you want to do a damage control in adverse condition or some action you need to take for making it like more business aligned or business is getting benefit from that. Then it comes second level, that is where Spark and Kafka and the Lambda architecture were taken, where they can take action when the events are happening, when the challenges are happening. That time they were taking the action. Now it's come the near real time with the Kappa architecture, where they can take decision immediately when the things are going on. Again, this is presented by Mike from Forrester in his one of the publication Perishable Insights. So the insight you are producing is perishing out. This essence is going out. Okay, now this is serverless Kappa architecture implementation. From hybrid, we are moving to serverless. One of the best provider of Confluent Kafka are the one of the best provider of managed Kafka services. This is something like your data is getting ingested, Confluent Kafka is handling it, complete serverless when you are talking, you are not managing the Kafka services. Then you are analyzing and then it goes on, like analysis, visualization, and you are storing this in your hand. Once the events you get into your data warehouse or your data lake, you are the king there. You can produce, you can transform any way you want. Again, what is the benefit of serverless or cloud services of Kafka? When we are implementing Apache Kafka, you can imagine we are getting engine to process. Now you have to make your own car. A lot of things breaks in between. When we are going for managed Kafka, again Amazon is there, Cloudera, Red, and many more companies are there. You get a car which we drive. But when we go for the cloud, it's self-driving car. You just sit, set the destination. You don't need to take attention of anything else. So that's why I'm proposing come to cloud-based serverless Kafka. Okay, this is what one of the permission I got to present here. When your budget is very limited, how you can go and implement the real-time infrastructure. Again, here we are not handling petabyte scale of data or like that. It is for my use case, internal data, CDC, audit log we are preparing, and this is the architecture we have solved. Every 10 seconds, again 10 seconds, we don't need real time. Even if everything log is coming to the system in 10 to 15 minutes, we are fine. So this architecture serves our purpose. The DMS job every 10 seconds is running, getting the raw data, sending the SMS notification, and complete serverless. No management is required. Lambda is triggered through SNS services. Lambda is converting to Parquet file and is dividing the rows into insert, update, delete. And then in 400 record set, it is divided into multiple files. The split Lambda we use, and then this putting in priority queue and non-priority queue. Cover now. This priority queue, non-priority queue again deals with multiple lambdas, splitting into multiple different lambdas, going into another queue services, and finally going into Aurora Postgres. Again, Aurora Postgres, like we found out for our use case, it's worked fine. Let's say failed there. We capped out this single instance, multiple connection. We capped out. It was capped at 500. Since we are splitting like creating complex lambdas at a time to process the file in near real time. Redshift was not able to take it. So it's going into Postgres. It can handle it. From Postgres, we are again doing batch processing, writing it into batch processing when I say every hour processing, writing into Redshift, and reports are served from both the places. This is one architecture. Another one is here, where this Kafka is at the client side and we are taking the data. Again, this is on the budget implementation. When your organization budget is on keto diet, you can implement this one. So we have we are consuming the events or whatever data processing we are getting from the APIs, we are processing it right in the Kinesis. Again, Lambda comes into play, and this Lambda is like AWS Lambda. That is again earlier architecture also AWS Lambda was there. It's processing the data, writing to RDS. Like, there are 2-3 places we are holding. One place we are writing in DynamoDB to search any missing data. Let's say sometimes what happens, some data are missing out. In the producer section, their data is not coming. That time, we are fetching from DynamoDB when it comes later, and then again writing into metadata services. In case some error happening, Lambda is not able to successfully write it. It's going to Kinesis stream, and then we are writing in S3 buckets. From there, we can process data stage. Okay. I have some CTA call to action for all of you. Whoever are interested in exploring the next architecture, like we've seen some architecture evolution. Now, from Lambda to Kappa, Kappa to what next? Anybody have any hint what this implementation might be? No? Okay. So this is present, and again this is not a new. When I say next architecture, this is about 8 years old architecture. All Google system work on this architecture, but they never came openly or they have publicized it. But their whole architecture system is working. It's a Jita architecture. As far I know, minimum 8 years ago they have implemented whole system they are running. Why it is called Jita? Because it has 7 layers of it. Completely democratized each component of the data processing. You split each component, serving layer different, distributed file system, everything plug and play you can do. One system is down, another backup will be up, it can be plugged in and everything will be in sync. No need to rush for firefighting mode. Code is breaking, data is getting lost, no need to do that. That's it, I can say.